Hi everyone. Today we're talking about powers of 10, what they are, what exponents mean, and what they're actually telling us to do. We'll work through some examples together, and I'll even show you a little pattern or trick that shows up with base 10 that's pretty handy to know. Let's dive into it. Let's start from the beginning. When you see a number like this, with a little number raised up top, that raised number is what we call an exponent. And the exponent does something very important. It tells us how many times that we need to multiply this number by itself. And so in this problem, we have 10 squared, or what we might say is 10 to the second power. And that exponent, 2, tells us that we need to multiply 10 times 10. So we have two 10s, we're going to multiply them. And that answer is 100. So if someone asks you what is 10 squared or 10 to the second power, you could say, I know it's 10 times 10, that equals 100. And we can do this with other exponents too. Let's try another one. So now we've got 10 to the third power. Now what do you think we're going to do there? Right, we're going to have to multiply 10 times 10 times 10. So see, we have 3 different 10s there. 1, 2, 3, because the exponent tells us that that is how many times we need to multiply it. And so 10 times 10 equals 100, and then 100 times 10 will give us 1,000. Now you might notice something. The number of zeros in the answer matches the exponent. And so here we have 3 zeros, right? And here we have a 3. Now that's a fun trick that we know when we do tens place. When we do exponents to the tens place, this happens to work out. But the important thing is that we're not adding zeros. So we're not adding anything. We're actually multiplying. Again, we're multiplying 10 times 10 times 10. And what's interesting is when we change the base number here, when we change this 10, that little trick doesn't work anymore. The zeros aren't just there. They actually completely change. And so let's take a look at another example that you might see. So what if our base number isn't 10? Well, let's try another number. Let's try 2. Actually, let's try 2 squared, or 2 to the power of 2. Now that exponent, that 2, still means the same thing. It tells us that we need 2 of this number, or multiply this number by itself that many times. So now we need to multiply 2 times 2 and we get 4. But did you notice something? The answer isn't 20. We don't just put a 0 in there. It's not 2 with 2 zeros in there. Not at all, because we're not adding zeros. We're actually multiplying these numbers together. And that's how exponents work. So that rule applies for all exponents. You're going to multiply the main number, the base number, by the exponent, however many times the exponent tells you to. All right, so now that we know how exponents work, let's see if you've got it. I'm going to put a problem on the screen, and I want you to pause, think about it, and see if you can figure out the answer before I show you. So here's the first one. 10 to the third power, or 10 cubed. Take a few seconds and think about what the exponent is trying to tell you to do. All right, so 10 to the third power means that we need to multiply 10 by itself 3 times, right? And so what would that look like? Well, 10 to the third power would mean that we have 10 times 10 times 10. I know that 10 times 10 equals 100, and if I multiply 100 times 10, that means I have 1,000, and so our final answer should be 1,000. So again, the exponent tells us it's a multiplication problem. That's really helpful. Now let's try another one. What about if I change the exponent to a higher number? I don't think we've done this one before. So what about 10 to the fourth power? What would that look like? Go ahead and take a second, think about what the exponent is telling us, and let's write out our equation. Great. So 10 to the fourth power means that we have 10 multiplied by itself 4 times. So 10 times 10 times 10 times 10. And we kind of just did this a second ago. But if you remember, 10 times 10 gives us 100, right? We multiply 100 times 10, that gave us 1,000. But now we have this 10 here. We need to multiply that by 10 again. And 10 1,000s is 10,000. So we know that 10 to the fourth power is 10,000. And that's really it. So to recap, powers of 10 are all repeated multiplication, not just counting zeros. The zeros are a helpful pattern, but the multiplication is what actually matters. In the next video, we're going to talk about what happens when you multiply and divide by powers of 10, and it's going to change the way you think about the decimal point. I'll see you there.